From previous data, it is known that 85% of a particular type of seed will germinate. Opie plants 90 such seeds and is interested in how many germinate. State the distribution he should use. Well, we've got 90 trials, probability of success of 0.85. So that sounds like a binomial. State a suitable approximate distribution. So the expectation for this one is 90 times 0.85, which is 76.5. And the standard deviation would be the square root of 90 times 0.85 times 0.15, which is approximately 3.39. So he could use a normal distribution with a mean of 76.5 and a standard deviation of 3.39. Now in part C, we're asked to use this to calculate the probability that exactly 75 seeds germinate. So the probability that x is 75 is going to be 90C75 times 0.85 to the 75, so that's 75 successes, times 0.15 to the power 15. And we can calculate that. There's no need for you to see me do that. And it gives me this. And I've just put down all the figures on the calculator display. Now in part D, use the approximate distribution to find the probability that exactly 75 seeds germinate. So using the continuity correction, for 75 we go down 0.5 and up 0.5. So let's bring in the class whiz and let's do that. So we've got normal CDF and our lower is 74.5. Our upper is 75.5. Sigma was 3.39. And the mean is 76.5. And that gives us this number, and I've written all of that down as well. Calculate the percentage error in using the approximate distribution. So that's the difference between them, divided by this one, and remember, we use that one because that's the exact, that was using the actual binomial PDF. And we multiply by 100 to turn that into a percentage, and it's out by 4.31%. That may seem like quite a large error, but the error would get better in using an approximation if our distribution, our original distribution, were less skew, and this one's really fairly skew at 0.85, and if n were larger.